Okay. So you wish me to start. So ladies and gentlemen, good afternoon or good morning, depending on which side of the world you're in. I'm very happy to welcome you together with Mr. Leboeuf of Natural Resources Canada to join to this joint EU-Canada event where we will promote traceability of battery minerals to ensure a socially and environmentally responsible battery value chain. So this seminar is a deliverable of the action plan of the EU-Canada Strategic Partnership on Raw Materials that we adopted in June and will advance the environmental, social, and governance objective of the EU-Canada Partnership. We announced in the EU Critical Raw Materials Action Plan a number of partnerships with resource-rich countries for 2021, and the first is the partnership with Canada. It was a priority for us to set up a raw materials partnership with you. Canada is a like-minded country in all senses of the word, a global producer of raw materials with a robust strategy to ramp up sustainable production of critical raw materials. The set bilateral dialogue on raw materials offered the mandate to advance with the partnership. Last week, Commissioner Thierry Breton met Canadian Minister of Innovation, Science and Industry, Mr. François-Philippe Champagne, and they agreed on the need to build more reliable supply chains for critical minerals and technologies. From EU perspective, the ambition of our industrial policy is to have an industry that creates value-added jobs in all regions across Europe, an industry that is driven by innovation, quality, and the respect for the environment, rather than by lowering labor costs. Batteries are a perfect illustration of all of this. We set up the European Battery Alliance and the Batteries Action Plan in 2018 with visible results in all segments of the battery value chain and in almost all member states. We proposed a legal framework setting clear rules to ensure that batteries perform and that they are produced sustainably, addressing the entire battery life cycle from transparent supply chains for battery raw materials through provisions for recycling and material recovery to minimum recycled content for future batteries. You will learn more about the batteries regulation in panel 2, Trends in Regulations and Standards Development, it is called. But at first, we will look at existing technologies and models for traceability and responsible materials, metals and minerals value chains with very interesting track record and potential in panel 1. In the concluding panel 3, I look forward to a discussion where industry leaders and panelists can share perspectives on traceability mechanisms and their role in responsible sourcing. It will be interesting to know more about the experiences from the industrial alliances, the European Raw Materials Alliance, ERMA, this we set up last year to strengthen resilience of complete value chains, and the European Batteries Alliance. Before passing the floor to Mr. Leboeuf, I want to mention an open call in Horizon Europe, Cluster 4, Digital, Industry and Space, that addresses technological solutions for tracking raw material flows in complex supply chains. It is a research and innovation action, and I invite you to look closer at this possibility. The deadline for application is 30 March next year. Now, thank you very much for your attention. I wish you a very successful morning or afternoon.
Good afternoon to those of you in Europe, and good morning to my Canadian colleagues. And thank you, Mr. De Nunes, for these introductions. My name is Luc Leboeuf. I'm the Director of the International Affairs and Trade Division within the Lands and Minerals sector of Natural Resources Canada. I have the privilege today to welcome you all to this seminar on tracing sustainable battery minerals and providing brief introductory remarks. I would like first to thank you all, especially my colleagues at DG GROW, for arranging this seminar as part of the EU Raw Materials Week. Canada is grateful to have such a strong ally in the EU, and we are pleased with this seminar, that this seminar is advancing the environmental, social, and governance objectives under the Canada-EU Strategic Partnership on Raw Materials. In line with rising global concerns about climate change and the environmental and social footprint of human activities, trade partners, investors, and consumers are becoming increasingly concerned about the provenance of the products they purchase. In recent years, this push for responsible sourcing has moved into the industrial sectors, including mining and metals production, prompting downstream users, such as automotive manufacturers and electronic producers, to demand ethically sourced raw materials. A number of governmental and private sector initiatives and standards have emerged to address the transparency issues in minerals and metal supply chains. These include the multilateral initiatives like the OECD's due diligence guidelines for responsible supply chains, industry initiatives like the Mining Association of Canada's Towards Sustainable Mining standard, and government-led initiatives like the EU's regulatory framework for batteries. To ensure compliance with these standards and regulations, one emerging solution companies and governments are increasingly turning to are traceability mechanism designed to monitor and track chain of custody from extraction to end consumer. Using big data management, traceability mechanisms can go beyond the technical reporting aspects of raw materials, such as chemistry or quality assurance, and provide detailed environmental, social, and governance metrics, including greenhouse gas emissions, water use, waste management, human rights, fair labor practices, and more. With the rise of this new emerging technology comes a host of questions, including how might traceability systems contribute to a sustainable battery value chain? What is the role of government and industry in supporting traceability mechanism? And how best can traceability mechanisms be incorporated into existing standards or regulations? So the goal of today's seminar is to answer these questions and generate thought-provoking discussion around how traceability will influence the raw materials sector going forward. We're very fortunate to have a stellar group of Canadian and European presenters from both the public and private sectors, who each bring their own unique perspectives and contributions to the traceability ecosystem. And before we get started with our first panel, I would like to inform you that we have a Slido tag to the seminar. It's hashtag CAN-EU Sustainable Batteries. So hashtag CAN-EU Sustainable Batteries. And you are invited to go into our Slido space to ask questions during the whole session. So moving on to our first panel. Our first panel of today's session will provide an opportunity to showcase innovative traceability technologies. We are joined by 4 esteemed presenters from both Canada and Europe who are at the forefront of developing and implementing traceability solutions. Each panelist will deliver their presentations on their traceability solution, followed by a brief questions from myself as the moderator. Our first Canadian presenter is Ken Fallu of Uptel Group, who will be discussing Uptel's work on the traceability of critical minerals. After graduating from Laval University in geological engineering, Ken has developed expertise in several large-scale companies and has been working for Uptel Group for 10 years now. He is now the head of strategy for mines and natural resources at Uptel, working on the implementation of advanced technological solutions to achieve transparency and traceability of sustainable materials, ensuring supply chain visibility. I now invite Ken to begin his presentation.
Thank you, Mr. Leboeuf. So maybe a little bit about Uptel. So at the beginning, Uptel Uptel, its mission is to, maybe next slide, please. Can we move to the next slide? Okay, thank you. So Uptel's mission is to provide responsible business practice for companies and to deploy our technologies in order to make a better world. So this is very strengthened in our core. Uptel is a company based in Quebec City, although we have operation worldwide in Europe, in Asia, in South America. We also won a prize for digital disruption in 2020 of the World Economic Forum, and it's very important for us, as I mentioned, for being responsible citizens. So we're a certified B Corporation. So next slide. So the Quebec government wanted to conduct a pilot project to ensure transparency of graphite combined with greenhouse gas emission with the different, like Mr. Leboeuf explained, parameters around traceability. So with the help of also Natural Resources Canada and Investissement Québec, so that pilot was conducted. So next slide. So the goal of the project was to develop traceability strategy to assess GHG in the value chain, provide a full mapping of the graphite value chain, because graphite was identified as one of the resources that we could use as a pilot project, identify the source of GHG with the parameter needed, and the traceability technology that would be used. So this project is also a project affiliated to the Global Battery Alliance towards the development of the battery passport. So in terms of delivering the project, the participants were Uptel, providing the technology, Propulsion Québec, who are helping, bringing the partners together and building up the ecosystem. Nouveau Monde Graphite, which is a mine of graphite that's currently in production or demonstration for full production in Quebec province. And CIREG, which is a research center on life cycle and GHG research. Next slide. So this is a brief overview of the supply chain of Nouveau Monde Graphite, where we have extraction, concentration, transformation, and then shipping, where the different traceability systems were connected. Next slide. So just to give you an overview of what these operations would be, so you see here on the left operation at the mine site, where it's called at the pit, I would say. It's an open mine operation. At the transformation, where the mineral is brought in to be transformed, and the final product, which is the different bag of graphite concentrate to be shipped out. Next slide. So this is a summary of the traceability steps and the associated data collection we've done in order to do traceability for this project. Considering that's in the field operation, there was no way to collect the data outside of providing some mobile application to collect information at different levels. So we started any unit was traced related to a blast. So whenever there was a blast operation, data was collected. Whenever was a processing operation at the pit data was collected, as well as whenever the transport of this mineral was brought to the concentration facilities. Then at the concentration, there was some information available from an Excel document. So this Excel document was imported within the data system. And then at the end, we could provide some reporting tools. Next slide. In order to do the GHG, we had to collect a lot of data in order to bring this information back and get a real evaluation of the GHG impact, and not just overall assessment yearly on a yearly average, but on a weekly basis, in order to Nouveau Monde Graphite to get a real feel of what their operation and GHG impact would be and how could they improve. So we're collecting data with the mobile application in terms of the different operation they would do, either as transporting, loading, blasting, pumping, and the different machinery that's used, along with the consumable that are used, either diesel, salt, or blasting agent that will be used towards that. Next slide. So all of this data with the hours operation, with the number of kilowatt hours that were used for processing the mineral, this is brought into a GHG model that was designed by CIREG. And that model allowed, with the different traceability data and the collected information, to provide feedback on the GHG result for each of these operations at any moment in time during the process of mineral. Next slide. So the result of the pilot project was the implementation of a comprehensive traceability system that would be demonstrating the compliance to ESG standard, and it's aligned with the Quebec roadmap for a clean, traceable, and circular battery value chain. Technically, this mineral that now has an ID and a digital footprint along with the GHG information, this information could be passed on to different stakeholders along the supply chain in order to go up to a full car battery. This is also highlighting an environmental and social responsible mining operation. And like I said, this is done in collaboration with the Global Battery Alliance for the battery passport. And the data here is fully compatible with what would be brought in eventually for the battery passport in the future. And this brings data collection analysis of real-time information, providing perspective for Nouveau Monde Graphite to improve the performance and also get a real life of what the GEG impact would be. So to finish, this is a view of the dashboard that would be resulting from the traceability program. So you have different bags with their weight, their characteristics, when they were blasted, what time they were processed, and the total GHG impact that would be associated with each of the bags. So thank you. So we can go on to the, maybe there's, I'm not sure, checking the time, but.
Yeah. Merci, Ken. Thanks, Ken. So yeah, thanks for getting things underway. We're just going to move right away to our second Canadian presenter, which is Ryan Foreman of the Ministry of Energy, Mines and Low Carbon Innovation for the Government of British Columbia, who will be presenting their Digital Trust Marketplace project. Ryan is an executive member that has worked with the province of British Columbia for 16 years. The majority of his career has been spent in policy and transformation design within the natural resources sector. And most recently, he is leading a significant digital effort that was recently launched at COP26. And this project, the Mines Digital Trust, is leading the way by creating a digital service and convening an ecosystem that brings together producers, purchasers, and investors of those raw materials to scale trusted credentialing in the mining space. So thank you, Ryan, for being here so early in British Columbia. It's for everybody else to know, it's 5:48 right now in the morning. So really appreciate your presence, and I turn to you for your presentation.
Thanks so much, Luc. Pleasure to be here. I successfully did not wake up my 3 little children who are sleeping upstairs right now, so I'm staying on side with the family, and I found a quiet corner early in the morning here out on the west coast of British Columbia, and do want to acknowledge our province is currently under a state of emergency from significant flooding, and want to acknowledge the first responders that are helping many of our cities right now. So as Luc mentioned, out in BC here, we are currently working on a digital project that is intended to bring together a variety of different players when it comes to data and trust, and how we can all convene in one open source technology project. This started really around what's the role of government when we get into this ESG space. Where do we provide value? Where don't we? What data sets within the government are material to investment decisions? And then when you get into supply chain tracking, what data sets are material to the work that the likes of Ken's doing and other colleagues on the call this morning around traceability when it comes to provenance. And so we know transparency is key for this next sort of digital leap in where we're going around traceability. We know that validated data is important. So who is the trusted authority to issue data sets? And how do we give or provide a means that everyone can convene and be able to exchange what we call verifiable credentials in a way that can scale into both supply chain projects, but also into global scale carbon accounting. So we can go to the next slide here. So we know that the demand for critical metals and minerals is growing. BC's Canada's largest producer of copper, which is key to, of course, the energy transition. We're a major producer of met coal. This coal used for steel making, of course. And we also got many critical metals and minerals required for the purposes of this discussion, development of batteries for zero emission vehicles. Go to the next slide. So the intentions of our project that we have embarked on here is around, again, supporting materiality of certain sourcing decisions. We're leveraging a tech stack called Hyperledger Aries. The BC government's the only subnational that's established our BC Business Registry on open source code. What we took on in our project was how do we now move from sort of a stagnant database approach to enable specific credentials to go into a digital wallet of a BC business, BC operating mine. And so we see in terms of some of the credentials right out of the gate here that BC is looking to issue is around permits, which of course is point of origin, BC business registration, and emissions credentials for footprint of our major mine sites. And so in the demonstration that we launched at COP26 last week, that included scope 1, scope 2, and the emissions intensity for one of our major mines in Princeton, British Columbia. We're using verifiable credentials to issue these, so these are very powerful uses very powerful cryptography. They're tamper-proof and secure, and what we want to do is give self-sovereign control to our organizations to make decisions about how they exchange these credentials into larger marketplaces. Next slide. Great. So our key goals here, we've been at this project for a year now. The very first one was around interoperability. We know that businesses need choice, and they need to be able to select who they are able to choose. If we're talking about traceability, they need to be able to work with different companies that they may be doing business with and receive credentials from different companies, as well as the provincial government for those data points that make sense being issued from the province. So we've designed an enterprise-grade digital wallet and have been working on interoperability testing with a suite of different wallet providers. We're interoperable with nearly a dozen now. The demonstration that I noted earlier was with IBM's wallet, and so we're continuing to grow this and know that this is going to be fundamental to making sure that this project can scale. Area of this focus this year will be around integration with closed blockchain solutions. So this is traceability companies that are leading the way. We again would want to convene an ecosystem where we can get credentials into the control of operators, and they can then use and distribute these credentials in the manner that they see fit. And third, the big one here is this is, we envision over the next, 5 to 10 years, the open source system for data and transparency really accelerating. And we're just trying to get Oh, I think it kicked me out there for a second. Am I back, Luke?
Yeah, you're back.
Okay. All right, go to the next slide, please. So as I mentioned, over the last year, we've convened a sort of core project team to understand how we could issue credentials. This has been around with Copper Mountain Mining, again, the mining site in BC, the Open Earth Foundation. They're a nonprofit out of California. PricewaterhouseCoopers as representing a auditing function for a mine site. We know that they issue credentials to mines that would be important for us to consider. And we'll be hearing from my colleague Ben Chalmers with the Mining Association of Canada, who we've most recently started discussions with around the Towards Sustainable Mining Protocol and how certification bodies can be involved in this type of work as well. So next slide.
oops, it looks like Ryan just lost connection. So we will just move on to the next presenter. Sorry for this technical difficulty. So we will now be turning to our European presenters. We are joined by Dr. Harri Kaikkonen of Batteries Finland, whose presentation will focus on the sustainable processing and traceability of battery metals, minerals, and metals. Dr. Kaikkonen works as a technology specialist at the Geological Survey of Finland in finding commercial opportunities for these. His expertise includes technology development in circular economy environments, digital service development, and agile development. He has previously worked as a project manager in large-scale indoor navigation projects and mobile application development. Dr. Kaikkonen holds a doctoral degree in industrial engineering and management and has written several journal and conference articles on the use of agile methods in product development. I now invite Dr. Kaikkonen to begin his presentation.
Thank you very much for the kind introduction, and thank you very much for the opportunity to present our project BATTRACE. As you said, I work at the Geological Survey of Finland, and I'll be giving a brief project overview of the BATTRACE project, where we use geo-based fingerprinting as a traceability solution for battery metals. Next slide, please. So in a nutshell, BATTRACE is a Business Finland funded project here in Finland, where we have a network of commercial companies working in the mining sector, providing samples and feedback to our research, where we develop technologies both for the traceability technologies, but also for the sustainable processing of battery metals and minerals. But in this presentation, I'll be focusing on the traceability aspect and specifically to geo-based fingerprinting that we use. Next slide, please. So just as definitions for traceability, we talk about the ability to track a product at the different stages of the value chain to the origins of the source material. And when I talk about geo-based fingerprinting, I'm talking about the process of determining the origin of a material based on analyzing the properties that it has based on the geological environment from which it came from. So we're talking about the natural properties of the metals and minerals, instead of the artificial fingerprints, which are sometimes used, for example, in the gemstone industry to print fingerprints to products. But that is not the case in what I'm talking about. Next slide, please. So what is geo-based traceability, and what types of things can we look at? So going from left to right in this picture, we're going from the macro level to all the way to the atomic and isotopic level of a ore sample, perhaps. So for example, on the left side, we can take a look at the bulk mineralogy composition of an ore sample to kind of have a very large overview of what minerals an ore sample or a rock sample may have. In the middle, you can see an electron microscope image of those minerals, so we can take a look at the texture composition of those minerals. Further than that, we can take a look at the crystal structure of those minerals, all the way to the mineral composition or the elemental composition of those minerals, all the way to the trace minute elements and the isotopic components of those elements as well. So we're going from very macroscopic level all the way to the isotopic level to get these fingerprints of a given sample. Next slide, please. In general, the workflow goes in a sense that when we get a sample, specifically perhaps an ore sample or a refined sample of some kind, we have to do some sort of preparation for the sample, and then we use analytical methods, laboratory methods to get the properties shown in the previous slide. And then we have to do some data analysis to those properties, and we use then compare those fingerprints or those properties to get a fingerprint which we can then compare to a reference database. So in order, of course, for us to be able to determine the origin of a sample, we need a reference sample from the location that we're comparing it to. Next slide, please. So in terms of the different properties that a sample may have, some of them will stay further along the value chain when the product is being refined. So for example, looking at the mineralogical composition of an ore sample when it gets picked up from the ground, it's clear that most of those minerals will be reduced from the product as it's been refined to a battery metal or battery grade metal. On the other hand, some other properties such as the isotopic composition of it remains until perhaps to the final product as well. And one big part of our project is to define and find out how far along the value chain we can actually trace these properties of the element. Next slide, please. So of course, as is the case in all technology development, there are also limitations and challenges to our method. So the process itself, the refinement of the product changes the fingerprint. And at some point of the value chain, we just assume that we will lose the ability then to track these properties. There's also the case of what is actually the accuracy or resolution, perhaps, of how accurately we can pinpoint the location of a given sample. So can we say, for example, that a specific sample comes from Africa or Europe, or can we name it to a specific country, for example, Finland or Brazil? Or can we even go further into saying that it came from a specific mine in Finland? So that is all to be determined in our research as well. So finding out the accuracy of the method. Some challenges, of course, is that currently, at least, we're using a lot of expensive and extensive analytical methods to create these fingerprints. So at this moment, it's not very cost or time effective to do so. But hopefully, throughout our research, we're hoping to find kind of a minimum viable set of analytical methods that we need to use to create these fingerprints so that we can get it to be more cost effective and time effective as well to scale it up in a larger scale. Then there is, of course, in terms of scaling it up on a global scale, if we want to be able to pinpoint an origin of a sample on a global scale, we would then need a global reference database, which may not be feasible, at least in a very short time frame. But that's also that we're building up during our research based on public information, and whether or not there would be a commercial use for this technology, then we would also need a global database for this as well. Next slide, please. As a conclusion, at the current level of development, at least, this type of the method, the geo-based fingerprinting, cannot be used as a kind of a one-off solution for traceability in terms of where would we be looking at a specific refinery and analyzing all the shipments that come into the refinery and analyze the geological origin of those shipments. But instead, this could be used as a verification or quality control method, for example, in a sample where the authenticity of its origin is suspicious. So the good part of these natural properties of the elements and samples is that you can't, they're incorruptible. So our technology provides great forensic potential for verification and quality control purposes. And I think that is the case for most upcoming commercial solutions, which are already popping up for value chain traceability, not only in the mining sector, but in retail and logistics in general, that they all rely on the quality of the input data. And our method, at least in the mining sector, can provide to be a verification tool for that data. So we can actually verify if the shipment is what it claims to be. So in that sense, this kind of a fingerprinting method could provide to be a complement for all other existing and upcoming traceability methods in the battery value chains. Next slide, please. So thank you for the opportunity to present our product. It's a very short introduction, especially related to the technical details, but I'll be happy to answer questions now or later. You can find my contact information here. And on behalf of the Geological Surveys Traceability team, I thank you for the opportunity to present our project.
Thank you very much, Dr. Kekkonen. We will probably do questions after all the presenters have a chance to do their presentation. So we'll go back now actually to Ryan, who is back online, and invite him to finish his presentation.
Thanks, Luke. Okay, we can. Apologies for my network issues here. We can go forward to the next slide. So this is just an example workflow of what I talk about self-sovereign identity in the business community. So really what we're trying to cook up here, this is the idea of like personal digital ID, but for businesses, right? So there's different sides of government working on anything about like the health passports. What we're doing is how do we convene this on the business side? And so the workflow you see here, example, data from regulator flowing to mine site in the middle using open source technology, that mine site having control, and then again, them being able to issue or provide these certifications on their own and up to their discretion. Next slide. There's a lot of things going on here, but this is in a nutshell the big vision, at least aspects of it for the type of ecosystem we're looking at convening. And here you see our Copper Mountain mine in the middle, receiving emissions credentials and permits from the province on the left. On the right-hand side, they're integrated with PricewaterhouseCoopers as an auditor, receiving the Towards Sustainable Mining Protocol issued under the authority of the Mining Association of Canada. Bottom left, you see them being able to exchange these credentials to a purchaser of their choice or an investor. But up top, it gets more interesting. This is where our eyes are on, is how do you scale this thing globally? We've done integration testing with the Open Climate platform that the UNFCCC is piloting with through their new Global Innovation Hub. And so the demonstration we did for COP was taking these components and then scaling them into the global accounting system. So that's we don't want to pick a winner when it comes to who businesses are doing, working with. It's really about who's the trusted authority data, how do we give that control to our operators to use, and also integrate into the supply chain systems that my colleagues here are talking about. I think this whole thing, we got to start stitching this all together across all the different solutions you're hearing about today. Like we can't, it's just too important when it comes to climate and traceability. And so I think that this type of technology will be fundamental to putting us all on the same sort of footing with a certain degree of trust. Next slide. Maybe next slide. If there's a next slide. Yeah. So if you want, you can go online. We won't play it here today, but you can watch the video demonstration. It has our Minister Bruce Ralston introducing the project, and it shows a virtual demonstration of the interoperability between our enterprise wallet, IBM, and the Open Climate portal. And if you just go to the BC government's YouTube channel, you can find it. Or you can also take a look at the Mines Digital Trust ecosystem. If you Google that, you should be able to find that. Or perhaps the moderators here can provide the link out to folks afterwards. So I'll leave it there while my system's still behaving. I sure appreciate the time and happy to take some questions after the next speaker.
Awesome. Thank you very much, Ryan. Great presentation. So our final presenter for this panel is Anna Lidbom of TraceMed Sweden. She will be discussing how to trace the carbon footprint and recycled materials to ensure responsible value chains. Anna Lidbom is the head of sustainability at LKAB, a state-owned international mining and metals group that offers sustainable iron ore, minerals, and special products. As head of sustainability, Anna is responsible for developing and implementing environmental and social sustainability policies on circularity and resource efficiency, biodiversity, energy, and engagement with local communities. Prior to joining LKAB, Anna worked for the Swedish government in various positions, including as a negotiator for Agenda 2030 and the Sustainable Development Goals, a political advisor to the Minister for International Development Cooperation, and as a European Union institutional officer. Ms. Lidbom holds a Master's of Political Sciences from Uppsala University in Sweden. I now turn to you, Anna, to begin your presentation.
Thank you very much, and thank you for having me. It's a pleasure to be here to discuss sustainable value chains and to present the pilot project TraceMed. And as you said, look, I'm representing the Swedish mining company LKAB, one of several partners in the TraceMed project. Sweden have a strong mining cluster extracting, for example, 90% of the iron ore production within European Union and 11% of the copper production. So you can go to the next slide, please. Yes, perfect. And as been mentioned here in this discussion before, we see that the demand for metals and minerals in the future are rising, of course. And to sum up this picture and not repeating what others have been pointing out before me, I just the International Energy Agency's stats states that to achieve a net zero carbon dioxide scenario globally for 2050, it would require 6 times more mineral inputs in 2040 than today. So that's we can go to the next slide. Sorry, it's lagging behind a bit here. Okay, so knowing that access to metals and minerals are crucial for the European Green Deal, for example, and the fact that Sweden has unique potential to supply critical metals and minerals needed for the green transition, and also recognize a growing market demand for traceable environmental performance reporting through the value chains, we identified a need to find a system to track sustainability performance through the value chains. We can go to the next slide, please. So in short, the long-term objective of this project, TraceMet, is an international system making sustainability a competitive advantage by offering buyers and end consumers an opportunity to choose and demand more sustainable options, and also promoting sustainable actors, which in turn promotes the development of a sustainable industry. We can go to the next slide, please. The Swedish Industry Association of Mines, Mineral and Metal Producers took the initiative for the traceability system TraceMet. The project ran from 2019 until this year, 2021, managed by the Swedish Environmental Research Institute. And TraceMet has several strategic partners in the mining cluster, including LKAB and Boliden, also a mining company in Sweden, and key stakeholders such as Volvo Group, Scania, Electrokoppar, SSAB, and ABB. And the TraceMet project developed 2 different pilot systems. One follows the value chain for iron from the mine via steel production to buses or trucks, and the second applies to copper from mining through the manufacture of copper wire to finished electrical cables. And in this way, TraceMet shows how an internationally accepted system for certification and traceability can be designed to support a more sustainable metal production. We can go to the next slide. And we wanted to develop technical and administrative systems to certify the original of metals and minerals and their carbon footprint and proportion of recycled material. And also the system needed to be reliable, functional and distributed, so it could be used by different stakeholders throughout the value chain. Next slide, please. 2 design criteria was selected: mass balance accounting to report environmental performance per unit of material produced, and blockchain technology to permit access control, distributed and encrypted information, working as a consensus validation mechanism. Next slide, please. Our main result is that TraceMet shows that environmental performance can be attracted from mine to manufacture. And the system can be used as a starting point and decision basis for for the next step in development. And we are right now defining the value proposition for market access, or we can see how knowledge for collaboration with other initiatives in Sweden or internationally can be used. And collaboration with other actors could be about research and further development of the system, or about finding ways to implement a functioning system in the market. And we also explore conditions for adding critical raw materials and more sustainability performance parameters, such as biodiversity, for example. And the vision of the project is a global reach traceability system used by most major mining and metal companies, as well as by all manufacturing industries that sees the value of tracking the environmental performance of their metals. Yeah, thank you.
Great, thank you very much, Anna. Great presentation. Actually, I have 4 minutes for questions, so I will turn to you, Anna, for the first question, since your presentation is fresh in our minds. And the question I have for you is, in terms of regulatory framework, what is needed for the TraceMet concept to become mainstream? You're on mute.
So now you can hear me, right? Well, that's a good question. I think that we need to have a common system on how to collect data and how to follow transactions that's not being manipulated in the value chain. So it could be useful to have some sort of system in place from that perspective.
Thank you, Anna. And maybe now a question for Harry Kelkonen. And it's in terms of the scale up of BAT Trace. So could you speak a bit more in terms of what is foreseen in terms of the scale up of this initiative?
Yeah, well, it's based on a lot of factors. So, for example, the technology development itself. So whether we're able to kind of see a reduced amount of criteria in the technology to create the fingerprints that I was discussing, but also it's related to the aforementioned regulatory development. So what is the demand for traceability technologies in general, and how wide scale they are going to be spread on a global level. And that all depends, the technology development and the regulatory development, and the demand then affects the possible business model and the commercial potential of all traceability technology. So I think there are a lot of questions, and it appears to be that while we do our research, we get more questions than answers, but hopefully we're able to answer some questions as well. So still, we're hoping to get this on a larger scale, but in terms of just the technology, it could be used on a smaller scale as well. So we could be looking at a technology where we can say that it's locally produced. So we could, for example, prove that some material is produced in Europe, for example. So that could be a Europe stamp even without a global reference library for this technology. So a lot of questions there.
Great. Thank you very much, Dr. Kelkonen. So I'm looking at the time, and I think we will stop this panel here. So I would like to thank you all, the presenters, for your informative presentations and for setting the stage for the discussions that we will have in the next panels. And we will now take a short 5 minutes break before we begin panel 2 on trends and regulations and standards development. So thank you very much to all the panelists again.